Hello, good evening, everyone. So we'll begin with today's lecture. In the last lecture, we had gone ahead and talked about some of the axioms of rationality. And towards the very end, I had talked about what is, what is MRS. In some detail, we talked about that. What is monotonicity and what is monotonic transformation? And we kind of tried to understand how monotonic transformation it differs from monotonicity. Now, before we actually move to the actual topic for the day, which is Marshallian and Hickesian, I would like to go ahead and quickly give you one question. And you need to tell me whether one is a monotonic transformation of the other or not. So, no, Sneha, the assignment and the solutions of the assignment are already posted on the portal. You should be trying the assignment. We'll go ahead. And if there is any doubt in the assignment, you can post it either on Telegram or you can go ahead and ask towards the end of the lecture. Okay, so before we continue, quickly, you have to go ahead and give me a yes or a no. So my function is U is equal to X half ln X plus 3 by 4 ln Y. This is a utility function that I have given to you. We will talk about utility functions a lot in detail today. But I just want to ask if this is a monotonic transformation of a well-defined utility function or not. And just to give you a hint, a well-defined utility function should be of this format. U is equal to X to the power alpha, Y to the power beta. Whenever we see this utility function, this is a well-defined utility function. I'll talk about this in a little while again, but just to think about monotonic transformation, can we ask ourselves if 1 and 2 represent the same thing or not? So yes, you're saying yes. Anu is also saying yes. Okay. Just try to think about it. Yes, everyone. Okay, correct. So why beta? If I can go ahead and take log on both sides, then this will be ln u is equal to ln x to the power alpha, y to the power beta, right? And the property of log is that log mn is log m plus log n. So this can open up and I can get log x to the power alpha plus log y to the power beta. And then the next property of log is that log m to the power n is n log m. So I can bring this alpha down and I will get something like this. And now if I look at it, beta ln u kuch nahi hota. Ln u means log of a number. Log of a number can be a new number. So now if I look on the right hand side of this and the right hand side of this, they seem very similar. Maybe with alpha as half and beta as 3 by 4. So which means that the right hand side of the two things resemble each other. And therefore this is nothing. But in the background, this is like this utility function. The two utility functions are very, very similar. On the basis of this, you will see at least 6 questions with video recordings on your portal after today's class as homework. The first question of today's assignment will be on this monotonic transformation. So once we are done with the class, and you start doing the assignment, the first 6 questions will be exactly on this beta, where you have to check whether it is monotonic transformation or not. And there would be videos on that. So go ahead and do those questions also. Be very, very thorough with the concept of monotonic transformation. But after this, I will post those videos, because it will be solution to your assignment. Okay. Okay. Now, today I want to talk about convexity to begin with. And before we do convexity, I just want to highlight that this is very different from a convex set. In exam, both of these can be asked. One is called convexity, the other is convex set. The two things are very, very different. Let us think about convexity first. So when I talk about convexity, the definition says that you should be preferring weighted averages should be preferred over extremes. Weighted averages should be preferred over extremes. Let us go ahead and take an example of this to understand this concept. So what you can do is, you can go ahead and take some utility function. Let's take a well-defined utility function. U is equal to x into y. Let us hold the utility constant at 4. So 4 is equal to x into y. Now, if you start plotting this as we saw in the last class, this will come down like this beta. Here will be x and here will be y. Now, different bundles should give you 4 as the utility. So you can have maybe x as 1 and you can have y as 4. That will also give you the utility of 4. Or you can have x as 4 and y as 1, and that will also give you the utility as 4. Now, what convexity suggests is that if I go ahead and I take an average, some average, zaruri nahi hai ekdam half hi lena hai, any weighted average, I give some weight to this bundle and some weightage to this. If I take some weighted average and I formulate a new bundle, maybe in this case, I will give the average of exactly half, the weight of exactly half. So, I'm giving half weightage to 4 and I'm giving half weightage to 1. So I will go ahead and get 4 plus 1 by 2, which is 5 by 2, 2.5. So my bundle here will be the average of these two, which is 2.5. Similarly, I will go ahead and give half to this and half to this, should be 1, sorry, and half to this. So 4 plus 1 by 2 will be exactly 2.5. So I will have 2.5 here. But the bundle 2.5, 2.5 should lie here. This is bundle C. I can name this as bundle A and bundle B. So bundle C is the average of bundle A and B. If I ask you, calculate the utility of bundle C, what will happen? You will say this is utility from 2.5, 2.5. Beta, my utility function is x into y. So this will be 2.5 into 2.5. This will be 6.25. This utility of bundle C, this is clearly more than the utility of bundle A or B, which was 4. That means C will lie on a higher indifference curve. IC dash. So I went ahead. I took two bundles, A and B. I took a weighted average of these bundles. So usually we draw a line and take any point on that line. That's called weighted average. And that bundle, it lied on a higher indifference curve. So this bundle, this weighted bundle is preferred over the extreme bundles. This is the first definition of convexity. Now, if I were to generalize this, then we can do it in terms of x1, x2 also. Let's say that we have this IC. Let's say this is the bundle x1, y1. This is the bundle x2, y2. This is their average, x1 plus x2 by 2. Mind you, it should not always be given weightage of half. Kuch bhi weightage de sakte ho. I could have given 3/4 weightage to x1 and 1/4 weightage to x2. It should have been fine. So, any weightage to x1 and any weightage to x2. Right? Any weightage. Similarly, here also, I will give some weightage to y1 and some weightage to y2. Then, convexity suggests that the utility you will get from this weighted average bundle, this is the bundle, alpha y1 plus beta y2, this utility is more than the utility from any extreme bundle. Extreme bundle is this point A, which is x1 comma y1. This is my extreme bundle. I will get more utility from this weighted average bundle. Same goes for the other bundle. You can just write this down, that u of alpha y1, alpha y1 plus beta y2, alpha x1 plus beta x2, comma, alpha, what is this bundle? Alpha y1 plus beta y2. This should be greater than u of x2, comma, y2. This bundle, this extreme bundle B. This is what convexity means. That's the first definition of convexity. First definition. Beta, the second definition is underlined under Snyder and Nicholson. So if you have to read Snyder and Nicholson, I'm listing down, no need to go there. It says convexity can be proved through diminishing MRS. So if first I find MRS. MRS we know is the slope of indifference curve. Slope of indifference curve is MUX by MUY. Once you find this MRS, if this MRS is diminishing, if it is diminishing, then you have proved convexity. Another question you will see in today's assignment that you do after this class. You have to check for convexity using this definition, whether MRS diminishes or not. Let us take two examples. This is very often asked in exam. So question. Your utility function is x to the power, let's say, half, y to the power half. You could have written this as root xy also, same thing. This is your utility function. There are two things that you have to check. Does it have diminishing marginal utility? Does it have diminishing MRS? Two very different things. Or here we can simply say, does it follow convexity? That is what we need to check. In both cases, we need to check whether things are diminishing or not. In order to do that, the first thing it asks us to do is to find marginal utility. So let's find that out. What will be marginal utility of good X? How utility changes as X changes. That means you should differentiate this with respect to X, holding Y constant. So let's do that. I will get half X to the power half minus 1, Y to the power half. So this will be half X to the power minus half, Y to the power half. This is the marginal utility of X. Now, the question asks if this is diminishing or not. So in order to check whether something diminishes or not, we want to check how it changes as the consumption of the good changes. So if it is diminishing, if we want to check that it is diminishing, we want to go ahead and ask how marginal utility changes as I change the consumption of good X. If this is negative, then it diminishes. If it is 0, then it is constant. Marginal utility is constant. And if it is positive, then it increases. But for that, many students will just look at the sign of this. Now, this is just marginal utility. To move one step ahead to check whether it diminishes, increases, or is constant. So if I want to check whether this diminishes, I should be differentiating this again with respect to X. And when I do that, what do I get? Again, power comes down, power reduces by 1, and Y to the power half. So this is going to be minus 1 by 4, X to the power minus 3 by 2, Y to the power 1 by 2. When power is negative, it means it will just come in the denominator. So this is just minus 1 by 4, Y to the power half, X to the power 3 by 2. This is clearly positive. This side. This is clearly positive. This is also positive. The only thing I see is it is followed by a negative sign. So less than C. So you have to always check it with the sign, not the absolute value for this, because that's what we want to check, whether it diminishes or not. So I will never eliminate the sign for this case. Okay. So this is how we know it diminishes. But I'm leaving it to you to check whether MUY diminishes or not. This is what you have to do. So you will go ahead and find MUY. That means you will differentiate utility with respect to Y. And then whatever MUY you find out, you will differentiate that with respect to Y again, because we want to ask how utility of Y, marginal utility of Y changes as the consumption of Y changes. And if this is less than 0, then it will be diminishing. Again, one of the questions, yes, you're right, it will be diminishing. So one of the questions in your today's assignment will be based on checking what is diminishing and what is not. Okay. So this is the first part, whether your marginal utility diminishes or not. Now we want to check about convexity. We want to check whether we have diminishing MRS or not. So now we will find MRS. MRS will be MUX by MUY. So MUY यहाँ निकाल ही लेते हैं. If I differentiate this with respect to Y, what should I get? Power comes down and power is reduced by 1. So it will be half x to the power half y to the power minus. This is when you differentiate it with respect to y. Now, if one is diminishing and other is not, that's fine. It's just that it is not well-defined IC. So for example, for substitute goods, none is diminishing. You have a constant marginal utility, right? For quasi-linear, one will be diminishing, other will be not. So it's fine. I mean, they are different kind of ICs. It's just that if both are diminishing and MRS is also diminishing, we are heading towards a well-defined IC. That's the only thing. But you have cases where it may not be diminishing. Okay. So coming to the next, part here. So marginal utility of good X is this: half x to the power minus half y to the power half. And that of y is half x to the power half y to the power minus. If you solve this, this will get cancelled. Negative power, it will come in the denominator. Negative here, it will go in the numerator. So you will simply get y by x. Now, this is MRS. I need to check whether this is diminishing or not. मतलब मेरे को इसको differentiate करना पड़ेगा to check that. But with respect to what? With respect to X or Y? So beta, just think about this. This is X. This is Y. Whenever you move along the indifference curve, you are going from point A to B to C to D. You are increasing the amount of X. So when X is increasing, the slope, the MRS should diminish. That is what we're asking. See, here it is steep, steeper, going flat, going flatter and flatter. So this is the slope. Indirectly, I want to check if the slope goes from being steep to being flat. If the slope diminishes, slope decreases. So I should be differentiating MRS with respect to X in order to check this. Because I want to check if I want to check that the slope diminishes, I want to go from being steep to being flat. And that I will check always along the changes in good X. We can move along. You could have gone ahead and moved along Y also, not a big thing. But then you have to be very thorough with the signs. It will be opposite because you will be going from flat to steep. So ideally, you are not saying MRS is diminishing. You are saying MRS is increasing, right? I'm going from being flat. Slope is less to more, to more, to more as I move along with Y, right? So just to be along with the theory side, you always go from steep to flat. So you always check along the x-axis. That is why we differentiate with respect to X. Okay. So now if I differentiate for marginal utility of Y, yes, for marginal utility of Y, we can check whether it is, if I get your question, you can check whether it is diminishing or not. You can differentiate this with respect to y again and check whether it is diminishing or not. So if you differentiate this with respect to y, you will get this.
Excuse me, ma'am.
Yes.
Ma'am, I just want to ask you whether we can check it with the help of a graph for the marginal utility of y. That like we are moving along the IC. That marginal utility of y comes out to be root x upon 2 root y.
Mm.
Like, and if we are moving from left to right to the IC, then we can observe that x is increasing and y is decreasing. So from that, we can observe that marginal utility of y is increasing. But if we differentiate it with respect to y, then it is decreasing. So what should we consider? Like marginal utility of y is increasing or decreasing?
Okay. So basically, for this, what you can do is, if I want to check whether MRS is diminishing or not, we know that MRS is MUX by MUY. Now, if you have proved that MUX and MUY are diminishing, then you know that when you move from point A to point D, when you move from A to D, you are increasing the consumption of good X. And we know that as you increase the consumption of good X, marginal utility of X should fall. Because we proved that we have diminishing marginal utility. And from A to D, X is increasing. Similarly, when I go from A to D, we are decreasing the consumption of good Y. So marginal utility of good Y should increase due to the same law, right? So the numerator should decrease as I move from A to D. The denominator should increase as I move from A to D. And because of this, because numerator is decreasing, denominator is increasing, this entire thing should decrease. So that is also another proof to show that this is diminishing. If I get your question, this is another way to show that it is diminishing.
Ma'am, but if we do differentiate with respect to y in marginal utility of y only, then it comes out to be negative, which means marginal utility of y is decreasing. But if
as y is increasing, as y increases, this, the implication of this, whenever this is negative, but this means change. So this means how marginal utility of y changes as y increases. Change ka matlab denominator mein is always considered to be increased. So if I increase the consumption of y, marginal utility of y decreases.
so ma'am, in the end, we are considering that marginal utility of y is increasing, and here we are considering that marginal utility of y is decreasing.
Because beta, I am moving from A to D. So when I move from point A to D, y is decreasing. So basically, when we say this thing, that this is negative, it means that change in y and change in marginal utility of y move in opposite direction. That is why it is negative.
Ma'am, but the answer should be one, right? Like either the marginal utility of y is increasing or decreasing.
It is decreasing, it is diminishing. That is what we are saying always. When we are saying that this is less than 0, it means it is diminishing.
But here in this screen only, like MUY, you said it is increasing.
I am saying MUY is increasing when I am going ahead from A to D. So when I go from A to D, I am decreasing the consumption of Y. So in most simple terms, you can say when you increase the consumption of Y, then marginal utility with every additional unit should decrease. This is from your very, very basic class 12th concept. Dekho, when I say consumption of any good, suppose I consume the first unit, total utility is 10. I consume the second, total utility is 18. I consume the third, total utility is 24. तो बेटा when you find marginal utility, this will be 8, 6. Suppose यहाँ पे 4 ले लो. This is going to be, suppose यहाँ पे 28. This will be 4 and so on. So if I move like this in this direction, I increase y from 1 to 4.
Excuse me, ma'am.
Yes.
Ma'am, I got that point, but I just want to ask you, like, if we are moving on graph, like, can you just show the graph? Like the marginal utility of y comes out to be root x upon 2 root y, right?
It comes out to be this. Yes. Half root x by root y.
Correct. Like, and if we are moving on a graph from left to right, then x is increasing and y is decreasing.
Correct.
Which, and if we are implying that same condition on that marginal utility of y, which shows that the marginal utility of y is increasing.
How?
Like in the numerator we have x and it is increasing. And in the denominator,
in the denominator I have y. So when I talk about marginal utility of y, I will always ask how it changes as y changes, not as x changes.
So yeah, that's what I was asking to you. Ki like, can't we do it with the help of a graph? Ki like, can't we check it with the help of a graph, marginal utility of y and marginal utility of x, like as we do it in the case of MI?
We can, but then I cannot do it through an indifference curve. Why? Because in indifference curve, I am plotting the utility function. I am not going ahead. If I were to check what happens only to marginal utility of y or utility of y, I should have gone ahead and drawn this. This is marginal utility of y.
Okay, so in the marginal utilities, we have to consider in the change in x or change in y.
Yes. If I check the slope of this graph is MRS. Okay, so I can only comment on MRS through this graph. I cannot comment on MUs through the graph. I can comment on MU if I start going ahead and plotting what we used to do in class 12, that this is the total utility function. When TU is maximum, MU is this, MU is diminishing. I can't do this through this graph about marginal utility.
Okay. Got it, ma'am. Thank you.
Okay. Okay, so in the second part of the question, what we are doing is we are trying to check whether MRS is diminishing or not. And when we talk about MRS is MUX by MUY. So I went ahead and I found out what is marginal utility of good X. I found out what is marginal utility of good Y. And I went ahead and I found out MRS. This is the slope of this IC. Now, if I want to check whether this is diminishing or not, I must differentiate the slope with respect to X. So if I differentiate Y by X with respect to X, but Y is a constant. So differentiation of Y by X with respect to X is this, differentiation of 1 by X with respect to X. That means simply minus 1 by X square. So when you differentiate this, you will get minus y by x square, which is negative. That means that MRS is diminishing because when you differentiated this with respect to x, you are getting a negative sign. This is how we can go ahead and check whether MRS diminishes or not. So two things. If I were to check whether marginal utilities diminishes or not, you will differentiate marginal utility of a particular good with respect to that good. If it is good X with respect to good X, if it is good Y with respect to good Y. But if you were to check whether MRS diminishes or not, you will first find MRS, and after that you will differentiate MRS with respect to good X. If that is negative, then it diminishes. You can take multiple examples in this, and for each kind of utility function, you will get a separate answer. Let me quickly take you one more example. Let's say the utility function is x plus y. These are called substitute goods. Now, in this case, if I find marginal utility of good x, it will be how utility changes as x changes. When you differentiate this with respect to x, you will get 1. Similarly, when you differentiate marginal utility के लिए with respect to y, you will also get 1. So your MRS will be MUX by MUY, which will be 1. Now, we again need to check whether it diminishes or not. So does marginal utility of good x diminish? Let us differentiate this with respect to x. I am getting 0. No. Does marginal utility of good y diminish? Let's differentiate this with respect to y. No. Does MRS diminish? Let's differentiate this with respect to x. No. From this, because this is not diminishing, I know my ICs cannot be strictly convex. And in fact, it is true, as I will show you, that these ICs are simply straight lines. These are not convex. So very simple test to check whether marginal utility is diminishing or not and MRS is diminishing or not. Now, this was the concept of convexity. We must be able to compare this concept with another concept that students get confused with, which is called a convex set. But this is a maths concept. You will do this in your maths class also. And you will find this in my intermediate videos of maths also. But I just want to highlight a little role of convex set in microeconomics. What is a convex set? Any set such that you take any 2 points, you join it with the line segment, and that line lies completely within the set. That is called a convex set. Let us take an example. Okay, so no, Isha, when I say MRS XY, when we say MRS XY, it is MUX by MUY. When I say YX, it is MUY by MUX. You reverse it. So one asks, how many good units of Y are you willing to give for 1 unit of X? And one asks, how many units of X are you willing to give for 1 unit of Y? So it's just the opposite definition, right? So they're kind of reciprocal of each other, right? So when I say this is this. This is what we usually use. When I say opposite, then numerator becomes denominator, denominator becomes numerator. That's the difference. Yes, you're right when you say that for substitutes, the two can be equal because you just get 1 in both cases. Okay. So I hope this is clear. So now let's talk about convex set. For convexity, average is strictly preferred over extreme. Usually, we even are okay with weak preference. Weak means equal to को भी हम include कर लेते हैं यहाँ पे. But it depends on whether we are talking about strict convexity or weak convexity. So, you know, when I say strict convexity, I will have a strict sign. When I say weak convexity, weak matlab lines are weakly convex. No, they're convex, but not strictly convex. Then I also include an equal to, right? But for our well-defined ICs, you don't have this equal to sign. You are talking about a strict sign. Okay. Okay. So now comes the convex set concept. So let's say that, let's take a circle. And what I'm doing is, whatever area I'm shading, including the borders of the circle, this is the set that I'm talking about. And I'm asking, is this a convex set or not? So I'm asking, is this convex set? Now, in order to check this, within this set, you can take any 2 points, join it with a line segment. This line segment lies within this colored region. So yes, it is a convex set. Take another example. Let's say now also I draw a circle, but I shade the region outside this circle. This is the region. And I ask, is this region, my set is defined with everything universal except this circle. And I ask, is this a convex set or not? Absolutely, you're right. This is not a convex set. Why? I take any 2 points, I join it with a line segment. Some part of the line lies in the non-shaded region, right? So this is not a convex set. Now, let's say I take a circle, but I don't include the boundaries of the circle. This is a dotted circle. The boundary is not included. And I shade this circle. Everything inside the circle is included, but not the boundary of the circle. And I ask, is this a convex set or not? What would you say? Would it be a convex set? So you're not including the boundary of the circle. You're including everything else of the circle. Okay. So a lot of you are saying that this will be a convex set. But just think about it. If I go ahead, let's take one more example first. Let's say my circle is the only set that I want to include. That means the only set I have is this line. Now I'm asking, is this a convex set or not? So, no, okay. Everyone is saying, no, it's not a convex set. So beta, whenever you join any 2 points here with a line segment, you will see that this will not be part of the convex set. So which means that if I'm able to go ahead and find out any point which does not lie on the shaded region, it is not going to be a convex set. Now, a lot of the people will ask similar questions. Is a circle a convex set? Is a line a convex set? Right? Is a circle with interior a convex set? Without interior a convex set? And so on and so forth. On very similar basis, we want to go ahead and we want to ask, is an IC indifference curve a convex set or not? But it depends on something, and I will come back to that dotted part again in a while. It depends on whether we are talking about weak preference or strong preference or strict preference. And here I would like to go ahead and help you understand what are the two. So when I say weak preference basically goes ahead and it means that you will go ahead and include all points which are weakly preferred to the points on your IC, which means either you are, so if you remember, weak preference is X, R, Y from the last class. They're weakly preferred to your IC. So either you are indifferent between those points or you strictly prefer one point to another. R can be rewritten as this, which means my weakly preferred region will include all points on the IC and all points above the IC. This will be my weak preference region. Now, when I talk about this weak preference region, this will be a convex set. Yes, convex set. Because if I take 2 points and join it with a line segment, everything will be included within that set. Everything. So it will be a convex set. But now, if I take strict preference, it means that I am taking X, P, Y. I will only take those points which are strictly above my indifference curve, but not on the indifference curve. So I will be including all points above the IC, but not on the IC. My IC itself will not be included. So something like this, my IC itself will not be included in this region because I am talking about the strict preference. Now, although the IC is not included, right? But if I were to go ahead and compare any one point, I have to compare a point here with a point on the IC, right? Only then it is preferred to some point. So whenever we talk about strict preferences, even though this point is not included in the set, if you were to go ahead and join 2 line segments, 2 points through a line segment, you will say this is not a part of the set. So strict preferences are assumed to be non-convex sets. Only weak preferences are assumed to be convex set because I need a point for comparison. And here those point of comparison, when I say X or Y, the point which is being compared to another point lies on my IC. And that is included here when I shade everything, including the IC, but not here. So this is an important implication that will go ahead and be asked in exam. Only weak preferences are convex set, but not strict preferences. This is important conclusion from our exam point of view, right? And again, you can go ahead and mathematically you will be doing it in detail, but you can go ahead and refer to that intermediate video also. So Anu, why? Because when I say XPY here, I am saying, so strict preference means that I am shading only those points which are strictly preferred to other point. So if I go ahead and I say a point like, let's say A, and I say B, I am shading all those points which are preferred to my IC. So I'm saying B is strictly preferred to A. That is why A is not included in this set. But when I talk about the convex set, if I pass a line from B to A is not a part of the set. So how will I go ahead and make a line segment? If I can find one exception to joining 2 points by a line segment such that it is not completely within the set, it will not be a convex set. And this point A, this does not belong to my set through which I am doing this comparison. So it will not be a convex set. Here, this point A will be included because I'm including all indifferent points also, and I'm including all preferred points also. This will be a convex. Is this clear now? Okay. Now, let us move one step ahead and let us talk about equilibrium of consumer. Beta, this is the starting of a new topic. You can just highlight this and we are going to talk about, आज शायद एक ही हो पाएगा, but we will begin with Marshallian and Hicksian demand curve. To begin with, let us talk about a well-defined preference again. This is case 1. And my utility function is xy. And my budget line is given by px into x plus py into y is equal to income of the consumer. We know that if this is my budget line, this budget line is expressed through a downward sloping line like this, right? This is good x, this is good y. And when you put y as 0, if you put y as 0, you will get x as m by px. This will be m by px. And when you put x as 0, you will get y as m by py. This is m by py. So this is how you will go ahead and you will draw these this line. Now, if you were to go ahead and give a slope of this line, one of the easiest way to do this would be to go ahead and find perpendicular by base. So perpendicular will be m by py, base will be m by px. So this will be simply px by py. That's the slope of the line. Of course, it will be downward sloping, so you can have a negative sign included. Another way to go ahead and find the slope of the line can be when you go ahead and you do px into x plus py into y is equal to m. And you write this in the format of y is equal to mx plus c, right? So if you write this in the format of y is equal to mx plus c, you will find that whatever comes with x is the slope of the line. So I can just go ahead and say that if I take this here, it will be y is equal to m minus px by x, and I will divide it by py, just finding the value of y from this equation. And again, I will get the same thing, that this is the slope of this line. So the slope of the budget line is px by py. And we now know that the slope of indifference curve is MRS xy, which is nothing but MUX by MUY. Now comes, how do you find the equilibrium condition for well-defined preferences? The first way is the simplest one, that you do through the tangency approach, which most of you would know. So what do? You just have this budget line, you have an IC, and wherever the two are tangent to each other, that is your equilibrium, right? So if my utility function is x into y, MRS will be MUX by MUY. When you differentiate it with respect to x, you get y. With respect to y, you get x. So y by x should be equal to px by py. And this gives you y into py is equal to x into px. But this equation is important. Note that I'm trying to find out this equilibrium point. And I'm saying that this equilibrium exists where MRS and price ratio are equal. And from that equilibrium, I have got this equation. But just note here that y into py is the expenditure on good y. X into px is the expenditure on good x. We are saying that in final equilibrium, the expenditure on good y is equal to the expenditure on good x. I am spending equal amounts on good x and y. This was asked in one of the IIT questions. They had given in some other language that a consumer always spends 50% of his income on good x, right? So and if it is a Cobb-Douglas function, we know that he will be always spending the remaining 50% on good y, because they are doing equal consumption, equal expenditure on good x and good y. Now, we know that our budget line is xpx plus ypy is equal to income. Instead of xpx, I can put ypy, the two are equal. So ypy plus ypy is equal to m. 2ypy is equal to m. So y will be m by 2py. And x will be, you can just find this out, m by 2px by putting this here. Put the value of y here, you will get the value of x. This is important throughout till the end of your entrance exams. Not every time I will be deriving this utility function. You have to remember by enough practice that whenever you see a utility function of this format, xy, you will get y is equal to m by 2py and x as m by 2px. Yes, only in Cobb-Douglas. Only for this utility function that I have done. Right? This is the first method, better, to find equilibrium by equating MRS to PX by PY. Now, this demand, this, when you find X and Y in terms of income and prices, this is called Marshallian demand. The demand of the two commodities, the equilibrium demands that you get of X and Y in terms of income and prices, that is called Marshallian demand. So if I were to go ahead and plot this, this is equilibrium. This will be m by px and this will be m by py for good x and good y. Even for non-unit powers of x and y. By non-unit powers, we will progress to that. I will give you a generic thing also. When we have x to the power alpha and y to the power beta, we will do that in the next class. Okay, this is only when the powers are unit powers. Then it is m by 2px, m by 2py. Once you understand the general format, you can do it for any. Okay. M by 2px, yes, not m by px. 2 is there. Okay, so now, see, when we write D is equal to, when we write U is equal to XY, this is called direct utility function. Why direct? Because we are just writing utility in terms of X and Y. Then we find out X star, Y star. Like here I got Y star is M by 2 PY. This is my Marshallian demand. Putting the Marshallian demand back into DUF, direct utility function, will give you indirect utility function. So if instead of X, I write M by 2 PX, and instead of Y, I write M by 2 PY, and I find my utility, what will I get? U is equal to M square by 4 PX PY. This is called indirect utility function. Another kind of question that comes in exam: derive the indirect utility function of the following curve of the following utility function. So this is called indirect. What is indirect utility function? Utility as a function of income and prices. Now this itself has multiple properties, right, which we will discuss in the next class. But before that, one thing that I would like to highlight here is that this is the first approach, beta, the tangency approach. I just want to take you through another approach, and you can write that down as the Lagrange approach. Right. Now, whenever we talk about the Lagrange method, you have the main objective function and you have a constraint. Beta, Lagrange can only be applied if you have strict, well-defined preferences. For others, we will use other methods. It cannot be applied for substitute goods, for min goods, for max goods, for quasi-concave, except for concave goods. No. Just for your well-defined preferences of the format x to the power alpha, y to the power beta, I can go ahead and apply Lagrange. Otherwise, I cannot. First thing. Second, I can only apply Lagrange for an equality constraint. For inequality constraint in maths, we have something which is known as Kuhn-Tucker, not required in micro. So equality का मतलब क्या हो गया? That I am always on my budget line, not below the budget line. My point is on the budget, right? That is equality constraint. But third thing, we are also assuming the non-negative constraints, but I will not use them in the Lagrange. Matlab, I will always assume that my consumption of X is only positive and Y is also positive. But I will not show these constraints in the Lagrange function. This is just to be assumed that you should always get positive constraint, right? So how do I formulate a Lagrange? In order to formulate a Lagrange, I will go ahead and say Lagrange. I will write my function that I want to maximize, which in case was utility function xy. I will go ahead and put a Lagrange multiplier. And here I will write my constraint. So I wanted to maximize my utility subject to my budget constraint, px into x plus py into y is equal to m. But this thing, it will go on to the right hand side here. And that entire thing will come here. And this will be your utility function. Then you will go ahead and differentiate this with respect to x. You will get this. From here, you will get the equation y is equal to lambda px. You will differentiate this with respect to y. You will get this. From here, you will get x is equal to lambda px. This will be equation 1. This will be equation 2. You will divide 1 by 2. This will be py. And you will get this. You have to do the same steps every time. Differentiate it with respect to x, get the first equation, call it 1. Differentiate it with respect to y, get the second equation, call it 2. Divide 1 by 2, get this equation. And beta, if you look here, from here, I have got exactly what I was getting above. That the expenditure on good y at equilibrium is equal to the expenditure on good x. Now, differentiate this with respect to lambda. So when you differentiate it with respect to lambda, you will get this part only. यही तो इसके साथ multiply हो रहा है. So you will simply get m minus px into x minus py into y is equal to 0. Which means you will simply get m is equal to px into x plus py into y. This is nothing but your budget line. You can plug this here and you will get the same answer, that m is equal to, so px into x was equal to py into y. Px into x plus px into x. 2px into x is m and x will be m by 2px. So ideally the two things are doing the same thing. I am differentiating it with respect to x and y. But from there, I am getting exactly same equation that I got from equating MRS to PX by PY. I am finally putting it back into my budget line like I was doing above, and I am getting the same values of X and Y. Lagrange is useful if I have a complex constraint where I may not be able to understand certain things or a complex objective function. 90% of the time, even with your MRS equal to PX by PY condition, we will be able to solve because we can anyways do it only with well-defined preferences, right? So this is what your Lagrange method does. Now, what you have to go ahead and do is, as a homework, try it using method 3. But method 3 is method of substitution. I want you to try it. Method of substitution says, make your utility function in one variable. So your utility function was x into y, right? And your budget line was px into x plus py into y is equal to m. From here, you can find the value of m, of y. Y will be m minus px into x by py. You can put the value of y here. You will get m minus px into x by py. Your entire function that you want to maximize is now only in one variable, that is x. X के अलावा तो कुछ है ही नहीं. So if you differentiate this with respect to x and equate it to 0, you will get x star. Same ही आएगा, m by 2px. This is the third method. It's called the method of substitution. Make everything in terms of one variable. Once you have got your utility function in terms of one variable, then maximize the utility. We know how to maximize utilities. Differentiate it, equate it to 0. And you will get x star. Put it back here, you will get y star. So 3 methods we have learned today. All 3 are used to find Marshallian demand. The first is the tangency method. The second is the Lagrange method. And the third is the substitution method. In exam, it is up to you what you want to go ahead and do. I am fine with any. We are just concerned with what the final answer is, right? But for now, it is a good idea to practice all the 3 methods. For initial practice, just practice all the 3 methods. Okay. So we'll stop here. And in the next class, I will begin with properties of your indirect utility function. So we'll start by understanding what is homogeneity, how do you check that, etc., etc. Yes, all 3 methods will give same answer because they're doing the same thing. They're maximizing utility. So if you want to go ahead, I mean, you will just find it from here and there in bits and pieces. But if you want to go ahead and read a book, it should be Snyder. You can go ahead and read Snyder for this part. Okay. So beta, by Sunday, now let's just keep increasing the task. By Sunday, please try and do from your intermediate videos budget line, preferences, and utility. These 3 chapters should be done from the intermediate videos also by Sunday. On Sunday, you will have your first mock exam. It will be based on whatever we have done till now. Okay. No, Varian would not have all these concepts in detail. Okay, so CUET was different from what CUET used to be. This time for a change, they asked a lot of maths and stats question because maybe DSE was added this time. So it was different from the past year papers of CUET. The last question of the assignment. Okay, I will do that. Can you have semester? Can we follow semester 3 readings of Delhi University? Delhi University semester 3 readings are good for it. And actually, the only thing there is that they follow Varian for most of the part. So consumer theory is through Varian and producer theory is through Snyder. So you won't find a lot of these things that I do. Like, for example, when I go ahead and convert Marshallian to Hicksian demand using Shepard's lemma, you won't find that in Varian. But you would find that in Snyder. So it won't be sufficient semester 3 readings, but if you are going ahead and doing them along with the lectures, it should suffice. Lectures are important. They should not be missed. So if you have gone ahead and covered intermediate concepts, it's okay if you don't still know these 3 things because these ought to be done in the advanced concept. So don't worry. Okay, so can you quickly go ahead and post the last question of the assignment somewhere on the Telegram group so that I can clear your doubt?
Ma'am?
Yes.
Ma'am, can you please take the screen to Lagrange approach?
Yes, this one.
Ma'am, downwards. Yes, ma'am. Ma'am, how is lambda, change in lambda is equal to 0?
Okay, so basically what we are doing is, so Lagrange just says you differentiate and you equate it to 0 because Whenever we maximize or minimize, we differentiate and we equate it to 0. So that is why when I differentiated it with respect to x also, whatever answer I got after differentiating, I equated it to 0. Similarly, when I differentiated it with respect to y, whatever answer I got, I equated it to 0. There are 3 variables in Lagrange. One is how much x you should consume, how much y you should consume, and the third variable is called the Lagrange multiplier, which is lambda. So you must differentiate it with respect to lambda also and equate it to 0. Now, when I differentiate it with respect to lambda, everything other than lambda is a constant. So in this case, this is a constant, this entire thing. So when I differentiated it with respect to lambda, I got this because this is what is attached to lambda, and I equated it to 0. So when I did that, I got back my budget line.
Okay, ma'am.
Is that clear now? So you just have to go ahead and optimize. Optimization requires differentiation. If you have to maximize utility, so I'm consuming good X and Y. If I have to maximize my utility, I must differentiate it with respect to X and equate it to 0. So exactly same thing I followed with lambda also. Here I'm equating to 0, here I'm equating to 0, and here also I'm equating it to 0. This is how you do the method of Lagrange. Okay.
And ma'am, the one that you have written in the box, ma'am, how is that derived, ma'am? The pink below the pink one.
This one.
Yes, ma'am.
So basically, when you differentiated it with respect to x, you got this equation and you equated it to 0. So you got this. So when I'm differentiating with respect to x, everything other than x is a constant. So here from x and y, I will get y. And here with x, my coefficient is minus px. So I will get minus px. And I'm equating it to 0. So I will get y is equal to lambda px. Similarly, when you differentiate with respect to y and equate it to 0, you will get x is equal to lambda py. Now I'm just dividing equation 1 by 2. So 1 says y is equal to lambda px, 2 says x is equal to lambda py, and I divided it. So this gets cancelled and I cross multiply. So py into y is equal to x into px. This is what I've written here. Okay.
Okay, ma'am.
Okay. So question number 6 of the assignment. Okay. So what is the doubt here? Why is it not convex? Why is it convex? Okay, so let's take this. So it says Dhoni is a religious and believes in meditation. He is away from material things and values prayer and meditation highly. As he states his preferences, I like meditation. I would rather always do more of it. And I'm completely indifferent as to the consumption of material goods. So between meditation, he has monotonic preferences, which means he likes more of meditation to less of it. Denote M by the number of hours of meditation and C by the quantity of the material good consumed. We can translate these preferences as follows. When comparing two bundles X and Y with X is equal to this, Dhoni prefers X is given as M comma Cx and Y is given as M comma Cy. Okay. Dhoni prefers X or Y if and only if Mx is greater than equal to My. Provide the intuition for why in this case, why this is the case, and plot the indifference curves in the two-dimensional space. So in this case, beta, the question is asking you to go ahead and plot between meditation and between C. So between your consumption of the materialistic goods. So we can take meditation here. And material goods here. And it is saying that I want more and more of meditation. As long as I'm getting more of meditation, I'm fine. So I am not concerned with the amount of the material goods if you give me enough of the meditation. And whenever you go ahead and you increase the amount of meditation, that is when my utility is going to go ahead and increase. Now, on this basis, if I were to go ahead and plot the indifference curves, the indifference curve will come out to be either horizontal or vertical, depending on what your axis is, whether you're taking it on the x-axis or on the y-axis, right? Now, if I go ahead and I say, suppose this is how my IC looks, and whenever you increase the amount of meditation, that is when my utility will increase. Then this kind of preferences are non-convex. Because for convexity, I need that weightage should be preferred over extremes. So if my ICs are represented by vertical or horizontal ICs, these are lines. So these are non-convex. But we need to also understand the definition of convexity based on a little of maths. Although any vertical or horizontal or any line that I draw, it may not be strictly convex or concave. Any line otherwise is said to be both concave and convex. So, when we go ahead and draw something like this is strictly convex. This is strictly concave. But when I draw a line is both concave and convex, but neither strictly concave nor strictly convex. For ICs, usually we look out for strict convexity and strict concavity. But mathematically, we will say that a line is both concave and convex. Okay. Is that clear? Any other doubt that you have here? For monotonicity, more is preferred, right? So if you remember, for the definition of monotonicity just said that we want to go ahead and if I compare two bundles, if they have the same amount of one good and one has more amount of the other good, the other should be preferred. So if I just compare it for a line also, and I go from point A to point B, they have the same amount of good Y, but B has more of good X, and it lies on a higher IC. It gives me more utility. So monotonicity is followed in that sense. Okay. Okay. Anything else? Any other questions that we have? So just do the assignment before the next class that I'm going to post today, and then we will meet on Friday. Thank you.
Ma'am.
Yes.
Ma'am, in the example of substitute goods, MRS is 0.
No. MR is constant, not 0. Substitute good is this. MRS beta is MUX by MUY. If you differentiate it with respect to X, you get 1. With respect to Y also you get 1. So it will be constant, not necessarily 0. It is not diminishing. It is, MRS is constant, but not 0, huh? Any number. Okay, 1 second. When only convexity is mentioned in economics concept, you should consider strict convexity. No, you cannot apply because Aparna, convex set and convexity are different. Convexity was in 2 definitions. Either your weighted average is preferred over extreme, or you have diminishing MRS. That is convexity. Weakly preferred is convex set. So you should not be checking convex set when question asks about convexity. They are 2 different things. Okay. Okay. Thank you.